Testing 1, 2, 3. Blah, 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 blah. Okay. It's already. Hey guys, and welcome back to another video on the channel. In today's video, we're going to be looking at the Physics Paper 1 multiple choice for the QCAA syllabus 2021 paper. Okay, so this one includes 20 other multiple choice. You'll be able to use pretty much this data sheet when you are sitting this test here. But yeah, we'll just be covering pretty much the entire thing in this video. Okay, if you have any questions at all, try and tag the timestamp when the question is taking place and pretty much what your question is, obviously. Okay. And I'll try and get back to you as soon as possible. But otherwise, let's get straight into it. Okay. So, question 1. Leptons do not experience, and then we could give in a couple of things. So, weak force, strong force, gravitational force, electromagnetic force. Okay. So, leptons are like electrons, muons, and taus. Okay. They don't experience this strong force. Okay. So, that is the correct answer there. Okay. So, that's something you have to learn. It's not really something where it's like you go calculate stuff. There's just some things you have to learn pretty much. Okay. It does experience gravitational and electromagnetic force because we know electrons are subjugated to that. Okay. Question 2. Calculate the initial horizontal velocity of a projectile with an initial velocity of 38 meters per second at an angle of 42 degrees up from the horizontal. So what this means pretty much is if you have a projectile like this, velocity is 38 degrees meters per second, 42 degrees, I think I said 42 degrees up from the horizontal. Now the horizontal component will be this guy here. This is your u of x, your initial horizontal velocity. And that will be your constant velocity as well. So all you need is some trigonometry here. So that's your hypotenuse. This is your adjacent, so you're going to use cos. So it will be the hypotenuse, so 38 cos of the angle, okay? Then you chuck that into your calculator. So I'll just grab a calculator. And it should give you roughly about 28.23 meters per second. Okay, make sure you're in degrees when you calculate this. Don't be in radians. Okay, so the correct answer here is just B because that's the closest one there to it. Okay. Question 3. Identify the correct formula for mass energy equivalence relationship. Okay, this one is pretty easy. It's that one there. E equals mc squared is quite famous. This one here is for potential energy. This one's for kinetic energy, and this one is just plain out wrong. Okay. That's kinetic energy when the speed of light is your velocity. That is your mass to energy relationship. Okay. All right. Question 4. Diagram shows two charges, charge 1 and charge 2, separated by a distance d. There is a force F acting on the two charges. So whether they're positive or negative, there will be an attractive force or repulsion force. Okay. Calculate the magnitude of the force acting between the two charges if D is halved, okay? And the charge of Q is doubled, okay? So, if you move them closer together, the force, whether it's an attractive or repulsion force, will increase, okay? It will also increase if the charge of one of them is doubled, okay? Now, this is where Coulomb's law comes in. So, force is going to be equal to Coulomb's constant times the product of both the charges over the distance squared, okay? So this is the force at the moment. Now our new force is pretty much going to be K, and then one of these charges will go double, will go times 2Q, and we'll have Q. And the distance is going to get halved, so whatever this old distance was, it gets divided by 2, but that's all squared. So effectively what we have here is, alright, everything is, so if we're moving them closer together and we're increasing one of the charges, the force is going to increase, okay? So straight away I know it's not going to be A, okay? Now, when you halve the distance, you're effectively increasing the force by 4 because that half gets squared, which turns into 4. But you're also multiplying pretty much by 2 up here. And the way we can work this out mathematically is if we expanded this, we'd have 2 Q, so I just took that 2 at the front. Then we would have R squared, and then we would have pretty much the 4 on the top here, because you would have 1 over 4 squared all over 1, which would just turn into just 4 on the top, okay? So you effectively have 2 times 4 on the top, so that's going to give you 2 times 4, which gives you 8. So here, if we were to take out that, so we have 8, Q, kq r squared. We have our original force times by 8. So the correct answer is D. Okay? And that's how you answer that question there. A little bit of mathematics and a little bit of thinking as well. It'd be trickier if they like halve the charge and like halve the distance. But we've got to think about it logically. If you increase one of the charges and you bring them closer together, of course the force is going to increase, regardless if it's repulsive or attractive force. Okay. If you have any questions about this one, leave something in the comments and I'll try my best to answer it. Okay. Alright, question 5. So this one's something you have to learn about the Standard Model, what a meson is. So a meson is something that is made up of pretty much an anti-quark and a quark, okay? So you've just got to look for one that's made up of that, okay? So here, subatomic particles are made of 3 quarks. No, they're not. They're typically just 2. 1 quark and 1 anti-quark, so that is the description up there. So A is the correct answer, okay? Alright, question 6. Electromagnetic radiation is... and then we have the following. Extreme high frequency radiation emitted from the nucleus of some radionuclei. That's not really true. It's basically just light. Okay, so we want to find the best description pretty much for light. So here we'll look through here. Now light is pretty much, it travels at the speed of light, but it has electric and magnetic fields oscillating with each other perpendicular to one another. Okay, so here we want to look for words like that. So here B, the emission of energy as waves or particles, especially this is a bad description, okay? That's not really describing much about it. A wave of energy produced by oscillating electric charge. Now, this would have been correct, but they said charge, okay? It's an electric field itself, resulting in a mutual perpendicular electric and magnetic fields. Okay, so that's probably the best description so far, okay? Alright. Radiant energy consistent of synchronized oscillations of electric and magnetic fields or electromagnetic waves propagated at the speed of light. That is the best description. So this one has some elements that is correct, but this is by far the best description. So I'm going to go with D as the correct answer. Okay. Alright, question 7, sorry. Normal force is the force acting along an imaginary line, and then we've got all these descriptions. So a normal force is pretty much what is happening perpendicular to a surface. So if we think of an inclined plane, the normal force is perpendicular to this surface. If it's on the ground like this, then it's perpendicular, okay? So the correct answer is perpendicular to the surface, okay? Alright, question 8. Now this one was actually a bit tricky to do, mainly because you do a lot of calculations, and if you're not as strong as with the math here, you could get this one wrong, because all the numbers are very close. So here the diagram shows 2 displacement vectors. So notice displacement, not velocity, okay? Calculate the result vector above the horizontal axis when vector A is added to vector B. So basically we're adding these vectors together and we're just seeing what we're going to get. So pretty much we'll add, now this is strictly a vertical vector. We want to add this with the vertical component here, not this. That's very important, okay? So we have to calculate this vertical component and actually this horizontal component. So this vertical component will be 30 sine of 30, okay? And this horizontal component here will be 30 cos of 30, okay? So when we add the two vectors together, we're going to have, as your vertical component, 30 sine 30 degrees plus the 20, okay? And then this will still be our horizontal component because there is no horizontal component with this vector here. It's strictly vertical. So that'll be 30 cos 30 degrees. Now you want to calculate what these numbers are. So if you chuck this one to your calculator, it gives you 35. And this one, if you chuck into your calculator, it will give you 15 root, what is that? Here, I'll try. I can't even read my own writing. I'll calculate that again. 30 cos 30, 15 root 3. Okay, cool. So then you can use Pythagoras' theorem to work out this guy here, because that's what they're looking for. They're looking pretty much for whatever this velocity is and this angle here. You can work both of them out using trig and Pythag. So we'll use Pythag here. So square this plus square this and then square root the whole thing. So you're going to calculate 35 squared plus 15 root 3 squared. Chuck that into your calculator. Let's just do that now. And it should give you about 43.58, okay? So straight away, it's not going to be C or D, okay? So it's out of these two here, but the difference is the angle. So now we've pretty much got to use a little bit of trigonometry. So we'll just draw this diagram a bit better. So at the moment we have this. That's 35. That's 15 root 3. That's theta. Now we have the opposite and the adjacent, so you want to use tan theta because tan theta is equal to opposite on adjacent. Okay. All right, let's get rid of this stuff now. If you need that working, you just rewind the video. Okay. So here, so tan theta will be equal to 35 over 15 root 3. Then you want to tan inverse that. So tan inverse now, again, make sure you're in degrees, not radians. Okay, that's really important. Okay. Alright, so tan inverse that. And you should get, oh, my calculator's glitching a little bit. Tan inverse 35 over 15 root 3. 53.41. Okay, so the correct answer is B. Okay, because that's 36 and that's 53. Alright. Yeah, if you have any questions about that one, leave something in the comments, but let's move on to the next one. Alright, the Bohr atomic model describes an atom as. So basically we're looking for the best description of Bohr. Now, if you don't know what Bohr's atomic model is and you don't do chemistry, basically it is a dense nucleus with fixed energy levels around it. Okay, so we're looking for something like that. If you do chemistry, the Bohr model is what we use pretty much most of the time when we're describing an atom in chemistry in terms of the shells and stuff. Okay. Obviously there's little variations, but majority of the time that's fine here. So here, a small particle of any substance. That is the worst description I've ever seen. A small dense nuclei orbited by electrons. Now that is Rutherford's model, so that's incorrect. But the reason they put it in there is because that's quite familiar and you would have studied that, so if you weren't sure the difference between the two of them, a lot of people could actually pick B. C, electrons scattered throughout a sphere positively charged. That's another model. I'm not sure what that is off the top of my head. Yeah, the name will come to me later. Anyway, a small positive nucleus surrounded by negative electrons in fixed set orbitals. Okay, that's the correct answer. D is the correct answer. Alright? Alright, question 10. Proper length is the length measured in the frame of reference where the object is. So, this is special relativity. So, if you have something moving, proper length refers to anything proper refers to TO or LO. In this case, it's LO because it's proper length. And proper length is measured when someone's not moving, pretty much, okay? So, LO, in this case, would be measured if someone was on a rocket because they would measure the proper length, okay? So, the correct answer here is going to be A, at rest, okay? So, again, that's a little bit of a concept question, no calculate there, okay? Alright, question 11. Uniform circular motion occurs when an object is traveling in a circle with a constant, and we have a couple things. So notice they have speed, velocity, etc. We just need to distinguish the difference between the two of them. So, look at the back bit. The force of a constant magnitude acting parallel to the velocity. So, if something's traveling in a circle, the force is center seeking and the velocity is perpendicular. So these top two are incorrect because they're saying the force is parallel to the velocity. Okay. Now, a lot of people actually got this question wrong. The difference between these two is that this one's saying speed, this one's saying velocity. Now, we need to understand what velocity is. Velocity is speed with a direction. Now, in a circle, your direction of your speed is always changing. That means your velocity is not constant. So the correct answer is actually C, because the speed is constant, the actual number, how many meters per second, but the direction is not. That's why C is correct over D. And a lot of people would actually get that one wrong. I did. I know that for a fact. But that's how you know the difference between these two here. Okay? Alrighty. Question 12. Calculate the maximum height reached by a projectile with an initial velocity of 15 meters per second at an angle of 30 degrees up from the horizontal. So this is literally just a vertical motion question. Okay? So all we do is you set it up like a normal projectile question. Go to 30 degrees here. But all we care about is the vertical velocity here, okay? Because in a projectile, what causes it to go up and to fall back down is just the vertical velocity. It will increase and then hit 0 and then it will go the other way, okay? We don't care about the horizontal in this case here. So here, thinking about vertical, So we only need three things. Now, when it hits the max height, the vertical velocity is equal to 0 because it's going to start to fall back down. So we know v of y is equal to 0 meters per second. This is what we can calculate here. U of y will be 15 sine of 30. And then, of course, we know acceleration on the way up is going to be against it, so it will be negative 9.8. Oh, not 1. Let's just go 9.8. Doesn't really matter in this case here. Alright, so now we want to choose an equation of motion where we have these three and vertical displacement, okay? So the one that comes to mind is this one, v squared equals u squared plus 2as. So your final velocity squared equals your initial velocity squared plus 2 times the acceleration and the vertical displacement. In this case, just displacement, so you can update that with the prefixes if you really want to, but it won't matter in the multiple choice here, okay? We want to get this as the subject, so you want to move this guy across, so you have v squared u squared minus v squared subscript y minus u squared y equals 2gsy. Then you want to divide by the 2g, so I'm just going to write down here. And there we go. So now we just chuck these numbers into here. So you'll have 0 squared minus 15 sine, obviously you can calculate that number if you wanted to beforehand. So that, and then 2 times negative 9.8. The negative is really important in this case here because you have a negative on the top and a negative on the bottom. If you want, you can ignore them and just get the absolute value, but in this case here, it makes sense mathematically. Now, if you chuck this into your calculator, it should give you about 2.86, okay? So that means the correct answer here is A, because that's the closest one to it, okay? Alright, question 13, I'm actually going to rub this stuff out because I think we need a little bit of math with this one here. Alrighty, so this one here, calculate the orbital period of a satellite traveling around Earth with a radius of that many meters. Okay, so here we need to use this formula, okay? And I'll explain to you why. So I'll just write it out. So we have the Earth, which the satellite is traveling around, okay? Now this formula is used to calculate the period orbiting around a body, pretty much. And m is the mass of the body. We know the mass of Earth, so we know what that is. We know the gravitational constant, and we actually know the radius. Now this t here is given in seconds. So the answer we're going to get is going to be quite big, but we need to convert it to hours, okay? So here we just pretty much rearrange to get t as the subject. So you would multiply by r cubed to get this, and then you would square root it, okay, to get rid of that squared there, okay? Now let's actually just chuck in the numbers. So we know from our data sheet, so we go back to the formula sheet here, I don't think we used it in this video yet, down here, there we go. So mass of the Earth and gravitational constant are given there for you, okay? So here we'll just go and just chuck it in. So period will be square root, so 4 pi squared, and then that radius that we've been given, all cubed, that's really important, divided by, and then we have 6.67 times 10 to the negative 11, times by 5.97 times 10 to the 24. Remember, this is all under that square root, okay? Alright, so I'll just check this in my calculator. Alright, so you should get roughly this number. So 2518951. So that's in seconds. So if we want to convert it to hours, we need to divide it by 60 times 60, okay? Because there is 60 seconds in a minute, and there's 60 minutes in an hour. So if you divide that number by that, you're going to get, I'll just do it, 851 over. Alright, cool. So you should get 699.7. So that's in hours, which matches here perfectly, okay? Because 6.99 times 10 to the 2 literally just means move this decimal 2 across, so 6.99 hours. So the correct answer for this one is C. If you have any questions about this one, leave something in the comments. Okay. Alright, question 14. So, moving electric charges in a magnetic field experiences. So, a decrease in charge and increase in charge. When it moves in a magnetic field, the charge doesn't change. So A and B are incorrect straight away. Okay. Now we got to use our right hand rule. So if you have your right hand, you can use this to work at the directions of pretty much where stuff goes. Okay. So your magnetic force is perpendicular to your palm. Your fingers are your magnetic field, and your thumb represents not only just current but velocity as well. Okay. So when an electric charge moves in a magnetic field, the field is always perpendicular to its direction, and it's also perpendicular to its force. So these are all at right angles to one another, okay? So here we need the best description of that. So the force is parallel to the direction. That's incorrect because of the right hand rule. The force is perpendicular to the direction. That is correct via the right hand rule. So straight away I think D is the correct answer, okay? Alright, question 15. Which Feynman diagram shows an electron interacting with one another? So basically we just got to look for two electrons, and we need to make sure they're drawn correctly. So if they're electrons, they need to be going like this into a vertex and like this out of a vertex. So here those ones have positrons because they're facing the other way. So if they're antiparticles, they're facing down like that. So it's not that one. That one's a neutron to a proton. It does have an electron there, but it doesn't have two electrons interacting, so that's incorrect. This one has positrons, so by process of elimination, the correct answer is A. And we can see why it's A, because we have electron here, they exchange a photon, and they scatter in different directions. Okay. Alrighty. Question 16. The weight of 5 kilos object on Earth is? Okay, so force due to gravity is mass times the acceleration due to gravity. So this one here will be 5 times by 9.8, which should give you 49. So the correct answer here is C. Alright, next one. Alright, question 17. This one actually stumped me as well. So electrical potential energy is, and we're looking for the best description of that. So basically, out of these ones here, so intensity in electric field in a particular location, that's not really mentioning much about the potential. Difference in potential tends to give a rise in electric current. That doesn't tell us what it is, it just tells us what it does. Work done in electric accelerating through potential of 1 volt, that's just telling something what it does. So the best description is this: the capacity of an electric charge carriers to do work due to their position in electric circuit. So it tells us what it actually is, okay? This is just saying other stuff, okay? Alright, question 18. A gravitational field is. Okay, so again, take this with a grain of salt with the QCAA syllabus. Don't apply general relativity here. Okay, so they're saying there's a gravitational field. Okay, so here we're looking for the best description. So a gravitational field basically means two bodies are attracted to one another. Okay, so a lot of people would pick A because they would say the net gravitational force per unit mass in a particular point in space. I mean, that is a good description. However, it only applies if there is matter around. If there's no matter, there's no gravity. Okay, so C is actually the correct answer because they say a particular region of space surrounding a body which results in another body experiences a gravitational attraction. Okay, so the reason why this is correct is because they're mentioning mass. Okay, now this one here is energy stored in an object, relative position of another object. That's just rubbish. Position in space where objects experience. So here they're not saying it's around a body. It has to be surrounding a body. Bodies, mass creates gravity. Okay, because of curvature of space-time. But again, I think you learn about general relativity in this syllabus, but that's the correct answer. Okay. All right. Question 19. A spaceship with a velocity of 9 times 10 to the 7 meters per second is measured to be 125 meters in length by an observer at rest. So we gotta know where this person is. Calculate the length of the spaceship measured by someone on board the spaceship. So someone down here can see the rocket and they measure it to be 125. Now they're actually seeing contracted length, so we need a distance larger. So because this distance here is smaller than that, I know for a fact that's incorrect. So this person here is seeing L. The person on the ship is seeing LO. Now remember, LO is greater than L, okay? So we're just going to use this formula, so L equals LO times square root, and this is the Lorentz factor, okay? Rearrange to get LO as the subject, so LO is going to be L over this. Now I'll just write that up there. So here we've been given, in this case here, as L. So we would go 125 over the square root of 1 minus 9 times 10 to the 7 squared over the speed of light square, which is 3 times 10 to the 8, and then the squared there. Chuck that into your calculator and you should get 131. And that's the correct answer there. Okay. Alrighty. Question 20. Straight away from the general look of it, it looks like a quantum question. So you want to be thinking E equals HF straight away. So a photoelectron with a kinetic energy of 2.5 times 10 to the negative 19 joules is ejected when a photon with a frequency of 1.3 times 10 to the 15 hertz is incident on the metal plate. Calculate the threshold frequency of light required to eject the photoelectron from the plate. Okay, that's a mouthful. So, here's what we've been given. So, we know with the photoelectric effect, if you shine light onto it and it's larger, so if the energy in is larger than the work function, which is the minimum energy required to knock off an electron, you'll have an electron pop out, okay? Now, the energy out is your kinetic energy. It's equal to your energy in, which is HF, subtract your work function, okay? Now, we know what this value is. We've been given it here, okay? So we know that the kinetic energy is 2.5 times 10 to the negative 19 joules, okay? Now, we've also been given the frequency coming in. So frequency is 1.3 times 10 to the 15, okay? Now, we don't have an expression at the moment for threshold frequency. Threshold frequency is the minimum frequency you need to get in. So the work function is actually Planck's constant times the threshold frequency. So you actually need this knowledge to chuck that into there. So you get kinetic energy is this, subtract this. Now you can already see they have something in common there. They have Planck's constant. So if you want, you could factor that out. And you could divide by it. So you get this, divide by Planck's constant, gives you that. Then what you could do is you could move the F across. So you can have kinetic energy over Planck's constant minus the frequency equals the threshold frequency negative, times everything by -1. So make that negative, make that positive, make that positive. And you've got an expression for the threshold frequency given these two things, and we already know what Planck's constant is. Planck's constant is 6.626 times 10 to the negative 34. Okay, so all you got to do is chuck all this information into this expression and calculate it. Okay, so this is what you would do. Again, this is multiple choice, only worth 1 mark. So if you get stuck on this question, just move on and go on to the short response, because again, the risk to reward ratio with a question like this isn't worth it, okay? But this would actually be a good short response question as well, so it's good to practice them anyway. So 6.626 times 10 to the negative 34 plus 1.3 times 10 to the 15 equals your threshold, okay? Now I've already calculated this. This should give you, what did I get? I'll just check in my calculator again. I've lost it. Okay, so negative 2.5 times 10 to the negative 19 over 6.626 times 10 to the negative 34 plus 1.3. Okay, so you should get about 9.22 times 10 to the 14. Okay, so you just go up and see which one matches. So the correct answer is C, because that matches it almost perfectly. Okay, that's how you do the multiple choice from 2021. If you have any questions at all, leave something in the comments and try and timestamp the question that you have a question about, and I'll try and get back to you as soon as I can. But otherwise, I'll see you in the next video.